Hello there and welcome to this second video on assembly language programming. In this one we're going to tackle one question and it's going to be worth 6 marks, and it's a little bit tricky if you don't know what you're doing. So firstly, let's just have a look at the question and break it down a little bit. A certain computer has an 8-bit accumulator with the following data stored in memory. Memory location 1A holds a character of a star or an asterisk. Memory location 1B holds the number 5. Memory location 1C holds the number 1. Memory location 1D holds a new line character. And new locations 20 or 20 that is to 2F are available as variable storage. The computer's assembly language instruction set contains the following commands: LDA-X, JGT label, add X, STA-X, JGE label, out X, DEC, X and CLR. Using only the assembly language commands shown above, write a program to produce the pattern shown below. Okay, so where do we start? What do we do? It looks pretty intimidating, this question, but it's really not. Okay, if you know, for example, how would you do this in code itself? So what we're trying to produce in its essence is we're trying to produce this here. Now, what is it? It's 5 stars and it's across 1, 2, 3, 4, 5 rows. Okay, so rows, we've got 5 of those and we've got 5 asterisks along the row. So let's call that, I suppose this is a column, I suppose. So we've got 5 columns, 5 rows. I'll put cols. Okay. Now the first thing I'm trying to think of in assembly language is, can I produce some kind of iteration to produce one row? Okay, one row of 5 stars. Can I produce that in assembly language? Well, they've given us the number 5 in 1B. They've given us an asterisk. They've given us the number 1 and a new line. So new line is to get onto a new row. The 1, I assume, is to increment or decrement, but I don't know. We'll see about that in a minute. Let's just map this out, right? Let's just map this out. So this is assembly language programming. Now, in assembly language, or well, in all computers, you have an accumulator, okay? Your accumulator is responsible for crunching numbers, doing things with numbers. So let me draw out my accumulator, okay? I'm quite a visual learner. I like to look at things and map them out. I've got something called 1A. I'll draw this as best as I can. I'm no artist. 1A, and that contains the asterisks that we need. All right. Underneath that, I'll draw 1B, and that contains 5. What else have I got? 1C. There we go, 1C, and that contains the number 1. Now that's 5 at base 10, that, by the way, and that's 1 at base 10. And then I've got 1D is a new line character, so how will I denote that? 1D, I'll just put new line in there. And I've got 20 to F. So I'll try and draw this as best as I can. 20. That will be 2, 1. I don't know how much more space I've got here. I've got 2, 2, 2, 3. You get the gist. That'll go all the way up to F, okay? Now, those last ones where it says variable storage, they're just empty boxes that I can use as and when I need them, okay? As and when I need them. But I've got 1A, 1B, 1C, 1D, all mapped out. I've got an accumulator there. And also, I imagine, I'll have... I'll just put up here like some kind of output because we need to actually produce 5 stars, so we're going to have to output something, aren't we? Okay, let's have a look then. The first thing I would always do, especially when doing any assembly language, is I'd always clear the register. Okay, clear, CLR, right? Now, clear the contents of the accumulator because I don't want anything on there that might mess up my calculations. I don't know if previous calculations have been left on there and it might mess up what I'm trying to do. Okay, so I always clear my register first in assembly language. All right. Now, what I want to do is I want to loop 5 times. Okay. Now, in order to do that, I need to populate some of these variable boxes with the value of 5. Okay. Now, the way I'm thinking about it is, in my head, I'm thinking, well, if I have 5 and I say, right, well, output a star. Okay. Decrement by 1, that'll go to 4. Produce another star, or asterisk. Decrement to 3, produce another star. 2, produce another star. 1, produce another star. And then have a check to say, if we reach 0, then we're done. And then make a new line. Okay? So then you would start on this one and reload 5 in, and you would go again. In my head, that's what I'm thinking. So I'm going, okay, start again, knock it down to 4, start again at 3, 2, 1, and then 0 again, new line. So you just basically, you keep knocking yourself down and then reloading the accumulator. So I need to protect this 5 at all costs so that it stays at 5. So I'm going to use some variable storage in order to do this. Okay, now that's the plan I'm going for. I'm going to start at 5 and I'm going to decrement every time, and I'm going to loop myself back for a new row, etc. So how do we write that in assembly? Oh, well, right. First step then, I want to put, what do these do? Load the accumulator with the contents of the memory location X. Right, so I'll do this first. I'll LDA load, and I want to load 1B, right? So 1B gets loaded onto the accumulator. Bosh. There we go. All right. Now, this is going to remain at 5 all the time. I don't want to touch it, okay, because I'm going to need it. When I start a new row, I'm going to need this again to start at 5 and then do my stars, knock them down. So I'm going to store that. Let's use the first variable storage, 20 then. So how do I get 5 from the accumulator into that storage location? It's going to be a store command. So the only store command I've got is stax. Copy the contents of the accumulator to memory location X. So that's what I'm going to do. sta, I want it to go into box 20. Okay? So load the 5 in 20. So I write this in here. That's what will happen. All right? Now 5 stays on that accumulator. It doesn't go anywhere. It copies the content. So that's what it's done. All right? Now, what I'm going to do next is think about where my rows and columns are going to go. Now I need 5 for my rows and 5 for my columns. And every time I start a new row, I want to make sure that I refresh 5 onto the accumulator, because this might not always be 5. So what I'm going to do is I'm going to say LDA 1B. Put a fresh copy of 5 onto the accumulator when we start a new row. So basically, what I'm going to do is going to put a comment at the side here, right? Start new row. Hopefully you can see that. That says row, by the way, row. So if I'm starting a new row here, I want to jump to this when I need to start a new row. Okay, I'll say that again. I want to jump to this when I want to start a new row. So I've got 2 jump commands here. So remember, when you're loading things from the program counter onto and you're putting it passing it to the memory address register, passing it to the memory data register. You can use jump commands to basically change the instructions that you're using, okay? And it's not very efficient for the processor, don't get me wrong, but very useful. So JGT label. So jump to the label if the contents of the accumulator are greater than 0. Okay? JGE label. Jump to the label if the contents of the accumulator are greater than or equal to 0. Now, when I go 5 and I produce a star, and I go 4, produce another star, I go to 3, produce another star, I go to 2, produce another star, I go to 1, produce another star, that's it. I don't want it anymore. If I go to 0, okay, I need a jump command to stop. Now this one says JGE, jump to label if the contents of the accumulator are greater than or equal to 0. Right. This one says jump to label if the contents of the accumulator are greater than 0. Now I think I need this JGT because this is all greater than 0, so I want to jump back if they're greater than 0. Okay, now that might not make sense at this point. Let me try and show you what that means as we write this code. So here I'm going to put a label because we're starting a new row. All right, I want to jump to this. So when you use jump commands like this, jump JGT label, I could write JGT row if I wanted to. Okay, and that would then jump to this point here in my assembly language. All right. Labels are just used to denote the stage at which you jump to. All right. They're not useful for passing data around or anything like that. They just move and change your the step you're going to execute. Now, what I'm going to do is I'm going to have 5 for my rows and 5 for my columns. So I'm going to need to do this. Let's say if this was for rows, counting down from 5, 4, 3, 2, 1, I need one for my columns as well. So what I'll do is I'll use this one as well for this. So I'll use STA21. There we go, right? You'll see why I'm going to do this in a second, because I want these two to have decrement my columns or my rows, and either one I can use really. So let's say this one was for rows, I would decrement from 5, 4, 3, 2, 1, 0. And for my columns, I would decrement 5, 4, 3, 2, 1, 0. And this remains untouched. When I create a new row, basically reload this one in so that it's refreshed and I can start counting down again. So what I'll do next then is I'll say, okay, so we started a new row, we stored 5 in there. I want to output, use the out command over here, out X, right? So I need to output a star. Star's in 1A, so I'll put out 1A. All right. So what that would do is that would produce this star in my output like that. All right. Then what I'll do is I'll say, right, once you've outputted the star, load this. Let's say this one was for columns. Let's use this one for columns. All right. We load 2-1 onto the accumulator. So I'll write my command for that. LDA21. Load that onto the accumulator. So there you go. 5's on there. And then what I'll do is I'll say decrement, DEC, decrement by register 1C. Okay, so decrement by 1, because there's 1 in 1C. Hopefully you can see that. And then what that would do is that would then chop this to 4. Remember, this has to be done in the accumulator because the accumulator deals with the arithmetic operations in this case. So decrement by 1C, then store it back in its register again. So I'll store it back in register 2-1. So that means that would go to 4, like that, because that accumulator gets copied back into 2-1. And then what I would do is I'll say, Right, we've gone down to 4, so we need to jump back and output another star. So what we need to jump to this point here, I think. So I'll put col on there. And I'll say JGT col. Let's go, to columns. There we go. So columns there, JGT column. So basically what's going to happen is, providing that we are greater than 0, so I'll just put there a little note on the side, greater than 0, jump back to columns. Okay? Now hear me out here, all right? Hear me out. We're on 4, okay? I've just got to this line. JGT column. Is 4 greater than 0? Yes, it is. Jump back up to column, output a star again. So you output a star like this, and then you go load register 2-1. So 2-1's got 4 in it. So you load 4 onto the accumulator. You decrement what's in the accumulator by the value of 1C, which is 1. So you decrement that down to 3, like this. You store it back in 21, or 2-1, sorry. So you store that back in there. Hopefully you can see that. And then is 3 in this register, is 3 greater than 0? Yes, it is. So we jump back up to column, output 1A. So I output another star, like so. Load, register 2-1. Load 3 onto the accumulator. There it is. Decrement by 1C. Decrement by 1. There it is, 2. Store that back in register 2-1. Store it back in register 2-1. Going out of space here. Then, stored it in there, done. Is it greater than 0? Is 2 greater than 0? Yes, it is. So we jump to column, output another star, load 2-1 onto the accumulator. There it is, 2's on the accumulator. Decrement by 1, so it goes down to 1. Load that, store that in register 2-1. There we go. Put 1 in there. I'm outside the box, sorry, ran out of space. Right, decrement, stored it, yes. Is 1 greater than 0? Yes, it is. So output another star, jump back up to column, output another star, load 2-1, so we load the register. So 1 goes onto the accumulator, decrement by 1, it turns to 0. Store 0 in register 2-1, 0. And then we say, is 0 greater than 0? 0 is not greater than 0, people. It's not greater than it. So 0 is exactly 0. So that's not good, is it? So that fails. Okay, perfect. That's what we want. We want it to fail because we've got 5 stars now. What we actually need to do is produce a new line. Okay, a new line. And when we say we need to produce a new line, what we actually need to do is we actually need to make a new row. So if this one up here in 20, if this was for my row, what I'm going to do now is I'm going to load 20 onto the accumulator, right? Watch this. Load 2, 0. So what happens, just get my eraser out for a second. Just get rid of these. And it's going to load 20 onto the accumulator like that. Okay? Then I'm going to decrement by the register 1C. So that actually goes down to 4. And then I'm going to store that back in 20. Right, put it back in. 5 goes down to 4. And then I'm going to output a new line. Okay, so I'm going to output, new line is stored in register 1D. So 1D gets produced, and now we create or start a new line. Okay, new line. When we've done that, and we produced a new line, we need to then jump back up here because we started a new row. Okay? So in order to do that, in order to jump to the row, we need to write a JGT command. That might be wrong. It might change that. It depends. We'll run it and we'll see what happens. I think it's a JGT command instead of a JGE command. So jump. Where do you want to jump to? I want to jump to the row, please. So there we go. We jump back up to row, and then we load register 1B. All right. So load register 1B. Watch what happens now, people. Watch what happens. So load register 1B, so 5 goes in there. Then I store that in 21. You know what 21 was used for, don't you? 21, or sorry, 21, because it's hexadecimal. 21 was used for our columns, and what I've just done is I've just reset it back to 5 by doing this command here. And then look, I move down, I output 1A. So look at this. I output 1A, which is a star. Then I go load 2-1. I load 2-1 into the accumulator. Oh, you know what's happening. We've done that, load it. We decrement by 1, so we decrement by 1. And then we jump because it's greater than 0. Sorry, store it back, we store it back. We jump because it's greater than 0, and then we start again. So watch what happens in real time, people. Yeah, watch what happens. We go back to 1A. We output a star. We load it in, goes down to 3. We store it in there, goes down to 3, store it. You jump again, you go down like this. You go to 2, 2, store it. Produce the star. We go down to 1, produce the star, right? You get to 1, and you load that in there. You get to 0, once it's loaded in, 0 like this. There you go. Once you get to 0, you go past here, you load 2, 0, which is 4. So you get rid of all that. You load 4 from 2, 0. And then you decrement it by 1. Decrement by 1. Store it back in there. So we're down to 3 on the rows. And then we output 1D, which is a new line, and you start again. Okay, and you keep going, and that will produce, if you keep going, people, if you keep going, that will produce all of your stars. Okay, all of your stars. And don't forget, if you clear it at the start, clear it at the end. So once you've finished all your rows and you finish all your 5 by 5s, you then clear your register. Okay. Now that's quite involved, people. I would recommend you go back, you get a piece of paper, you write out or you draw these boxes. You will see me, if I sat your exam, you'll see me with a scrap piece of paper scribbling boxes onto pieces of paper and then testing this out and seeing, making sure it's jumping to the right place, it's running the right logic, etc. Okay? If you need to go back and start again and follow me through, pause the video, try a bit, pause the video again, start it, play it, pause it, take it very, very slowly. You'll understand the logic that I've produced there for 6 marks. Okay? We'll do another question. So hang in there. Even if you don't get it, hang in there.